Hello and welcome to the Burp Suite course. So in this introduction, we're going to give you an overview of what we're going to cover throughout this course, what you can expect to learn, and a whole lot more. In case you are wondering, what is Burp Suite? It is a powerful set of tools widely used for web application security testing. Burp Suite is developed by Portswigger. It offers a comprehensive platform for various tasks, including web scanning, security testing, and vulnerability assessment. Now, our particular course objectives will include gaining a fundamental understanding of web application security concepts. You'll learn how websites function and the basics of HTTP, letter-by-letter requests, and responses. We'll also explore the fundamentals of web penetration testing and bug bounty programs. We'll then be able to understand the role of Burp Suite in web security testing, as well as its key and most popular features. So by the end of this course, I would expect that you would have mastered how to use Burp Suite tools, like proxy, intruder, repeater, and there's more. But you'll definitely gain hands-on experience because we're going to take you through some practical exercises and many examples. Now, perhaps to get the most out of this course, definitely it's recommended to have a basic understanding of web technologies, right? So familiarity with networking concepts as well as the HTTP protocol, that's going to be way beneficial. We've actually divided up the course into several sections, each focusing on specific aspects of web security testing and Burp Suite usage. So you'll start with the basics of web terminology and gradually progress to more advanced topics, culminating, where's the trumpets, huh? In practical exercises to apply your newfound knowledge. And you know what all this means, right? By the end of this course, you'll be equipped with the knowledge and skills to effectively use Burp Suite for web security testing purposes. Now, we're excited to embark on this journey with you, as well as help you become proficient in web application security testing, all while using Burp Suite. So let's dive in and start exploring the fascinating world of web security together. All right, well, hey, welcome back. So check it out. We're going to delve even deeper into the understanding of inner workings of websites. Let's have a look at the client-server relationship first. So you got to think of this client-server model as a conversation between two entities, right? You've got the client, which initiates requests, and the server, which actually responds to those requests. So when you type a URL into your browser and hit enter, you're acting as the client. You're asking a server to provide you with a specific resource, such as a web page or an image. So let's break down what happens behind the scenes when you request a web page. So you can think of this as the journey of a request, right? First is the request initiation. You type a URL into your browser's address bar and hit enter. Your browser sends a request to the server specified by that URL, letter by letter, asking for the corresponding web page. 2. Server processing. The server receives your request and processes it accordingly. Now, this may involve fetching data from a database, executing scripts, or even performing other tasks necessary to generate the requested web page. Number 3, response generation. So once a server has processed your request, it generates a response. This response typically includes the requested web page along with any additional resources. That means just images, style sheets, scripts, that kind of thing. But those are needed to render the page properly. On to number 4, delivery to the client. The server sends a response back to your browser, which receives it and interprets the content. Your web browser then renders the page for you to view and interact with. Now, at the heart of the communication process between clients and servers lies HTTP, or Hypertext Transfer Protocol. So this HTTP actually defines the rules for how messages are formatted and transmitted between clients and servers. This is the language that allows your browser to communicate with web servers and retrieve web pages. In addition to HTTP, several other Internet protocols play crucial roles in various aspects of web communication and functionality. Let's have a look at a few. HTTPS. This is the Hypertext Transfer Protocol Secure. So HTTPS is the secure version of HTTP, encrypted with SSL TLS, which are also protocols. It's important because it ensures secure communication by encrypting data transmitted between clients and servers, protecting sensitive information such as login credentials, payment details, personal data. Then comes DNS, or the Domain Name System. Now, DNS is responsible for translating human-readable domain names like www.example.com into IP addresses like 192.0.2.1 that computers use to identify and communicate with each other over the Internet. So DNS resolution occurs before initiating a request to a web server, enabling browsers to locate the correct server for any given domain. Then we got TCP, which is Transmission Control Protocol. So TCP is a connection-oriented protocol, and this provides reliable, ordered, and error-checked delivery of data packets between devices over a network. It establishes and then maintains a connection between the client and the server, ensuring that data packets are transmitted and received in the correct order without loss or corruption. So IP, the big daddy of them all, IP, Internet Protocol. Yeah, IP is the principal communications protocol that gets used for relaying data packets across network boundaries. So it defines the addressing scheme and routing mechanisms used to deliver data packets from the source, that's the client, over to the destination, the server, across interconnected networks. Which brings us to SMTP, and this is the Simple Mail Transfer Protocol. SMTP is an Internet standard for electronic or email transmission. It's used to send outgoing mail from a client to a mail server and between mail servers for message relay. SMTP ensures reliable email delivery by handling the routing and delivery of email messages between sender and recipient mail servers. Then we have FTP, which is the File Transfer Protocol. FTP is a standard network protocol used for transferring files between a client and a server on a computer network. It provides a mechanism for uploading, downloading, and managing files remotely, allowing users to exchange files securely and efficiently over the Internet. All right, so now that we know that, it's time to have a look at web page anatomy. So you may already know that web pages are composed of three primary technologies, right? We've got the HTML, which is the hypertext markup language, and this just provides the structure and content of a web page. Here's an example of HTML. Then we've got CSS, which stands for Cascading Style Sheets. But CSS controls the presentation and the layout of a web page. So here you see an example of CSS. And we've got JavaScript. JavaScript adds interactivity as well as dynamic behavior into a web page. Here's an example of Java. So these technologies actually work together to create the rich interactive experiences that we encounter each day on the web. So you see, by understanding the client-server model, the role of protocols like HTTP, and the technologies that power the web pages themselves, you're now better equipped to navigate the complex world of web development and security testing. Now, when we come back in the next video, we'll continue our exploration by examining the anatomy of HTTP requests and their responses in greater detail. We're also going to see the whole cycle of all the packages in Wireshark by the end of the section. So stick around, I'll see you in the next video. All right, so welcome back. Here we are, all the way in video 3, yeah? So we're going to dive into the intricacies of HTTP requests and responses, which is basically the backbone of communication on the World Wide Web. All right, so let's get a handle on HTTP requests. HTTP, Hypertext Transfer Protocol requests, are messages sent by a client to a server to initiate an action. Now, there are several types of HTTP requests, each serving a particular purpose. GET requests data from a specified resource. POST submits data to be processed to a specified resource. PUT updates a specified resource. Delete deletes a specified resource. Head is similar to GET, but only retrieves the headers, not the actual content. Options returns the HTTP method supported by the server for a specified URL. Here we'll break down the HTTP request, which consists of several components. First, we have the request line. Contains the HTTP method, the URL of the requested resource, as well as the HTTP version. Second, headers provide additional information about the request, such as the user agent, content type, and accepted languages. Third, we've got the body, which happens to be optional, and this contains data sent to the server typically used in POST requests. Now let's break down the HTTP responses. So the HTTP responses are just messages sent by a server to the client in response to an HTTP request. And just like requests, responses have their own set of status codes indicating the outcome of the request. 1XX, informal responses. So the request has been received and the process is continuing. 100, continue. The server has received the initial part of the request and is awaiting the rest. 101, switching protocols. The server is switching protocols according to the client's request. 2XX, success responses. The request was successfully received, understood, and accepted. 200, OK. That means the request was successful. 201, created. The request has been fulfilled and a new resource has been created. 204, no content. The server has successfully fulfilled the request, but there is no content to send in the response. 3XX, redirection responses. Further action needs to be taken to complete the request. So 301, moved permanently, means the requested resource has been permanently moved to a new location. 302, found. The requested resource resides temporarily under a different URI. 4XX, client error responses. The request contains bad syntax or simply cannot be fulfilled. 400, a bad request. The server cannot process the request due to client error. 401, unauthorized. The request requires user authorization. 404, not found. The requested resource could not be found on the server. 5XX, server error responses. The server failed to fulfill an apparently valid request. 500, internal server error, a generic error message indicating the server encountered an unexpected situation or condition. 503, service unavailable. The server is currently unable to handle the request due to temporary overloading or even maintenance of the server. All right, so now we're ready to have a look at this anatomy of an HTTP response. They are similar to requests, right? An HTTP response comprises several parts. Let's break them down here. First is the status line. So this contains the HTTP version, the status code, and a brief message indicating the status of the request. Secondly, headers. And these provide the additional information about the response, such as the content type, content length, and server details. Third is the body. And this contains the actual content sent by the server, such as HTML, JSON, or even binary data. Which brings us to the end of this video. So we've actually explored the fundamental concepts of HTTP requests and responses, including a detailed look at their structure, types, and status codes. Now, of course, understanding these concepts is crucial for effective web development and security testing. But guess what? In the next video, we're going to apply all this knowledge as we dive into some practical exercises as well as some demonstrations. All right, so we're going to have a look at the packages on Wireshark. See you next time. Wireshark, a tool used for creating and analyzing PCAP's network packet capture files, is commonly used as one of the best packet analysis tools. In this lecture, we will look at the basics of installing Wireshark and using it to perform basic packet analysis and take a deep look at each common networking protocol. If you have a general knowledge of networking basics, then you will be ready to begin. The installation for Wireshark is very easy and typically comes with a package GUI wizard. If you're using Kali Linux or the TryHackMe attack box, then it is already installed on your machine. Wireshark can run on Windows, MacOS, and Linux. To begin installing Wireshark on a Windows or MacOS device, you will need to first grab an installer from the Wireshark website. Once you have downloaded an installer, simply run it and follow the GUI wizard. If you are using Linux, you can install Wireshark with apt install Wireshark or a similar package manager. The first screen that we are greeted by when opening Wireshark is the main page that will allow us to specify our interface as well as apply filters to narrow down traffic that we are capturing. Here you can see that I have multiple interfaces to filter from. You may have more or fewer interfaces than I have. From here we can choose whether we want to perform a live capture on our interface or load a PC app for analysis. It is useful to note that the graphs next to the interface names show the activity on the interface. If an interface has a flat bar, it may be useless to attempt to capture on it, as no data on that interface is being picked up by the Wireshark client. If we begin by navigating to the green ribbon in Wireshark and select Manage Capture Filters, we can view a list of available filters. You do not have to select a filter. It will only help to bring down the number of packets being brought in and organize the capture. This is only a brief introduction to filters. For more information about filters, go to the Wireshark website. Once you have any capture filters you want selected, you can begin a capture on an interface by double-clicking the interface or by right-clicking and navigating to Start Capture. Depending on the network activity, you may see no packets coming in, or you may see packets streaming in very quickly. Once you're done gathering the packets you need or want, you can click the red square to stop capturing, and then you can begin your analysis. Looking at the screenshot, we see a sample capture. This screen is where you will do most of your analysis and dissection of packets. To open a packet capture, go to File, Open, and select what PCAP you want to analyze. From this screen, Wireshark gives us some important info about each packet, including packet number, time, source, destination, protocol, length, packet info. Along with quick packet information, Wireshark also color codes packets in order of danger level as well as protocol to be able to quickly spot anomalies in protocols and captures. This quick glance at packet information can be useful to track down exactly what you're looking for during analysis. Play around with the menus and various features of Wireshark to get a feel for it. Let's go to Kali and run Wireshark. You can open a terminal screen and type Wireshark to start it. So these are the network interfaces that Wireshark is able to listen to. Let me open another terminal screen and run the ifconfig command to see the network interfaces. So as you know, ifconfig stands for network interface configuration. So if we use the command without any parameter, it'll list all the interfaces available. We have ETH0 as a network interface to listen to. So now I'll turn back to Wireshark and double-click ETH0 to select it. Now Wireshark starts to listen to the Ethernet interface of Kali. And to create some traffic, I'll open a web browser and just visit an arbitrary website. And now we have enough packets to examine, so I'll click the Stop button at the upper left corner of Wireshark to stop listening to the traffic. So first, we have some DNS packets to find out the IP address of the visited site. We'll look at these kinds of packets soon, but right now let's just have a brief look. So a DNS query for the IP version 4, another DNS query for IP version 6. Don't worry about the versions right now. We'll cover them soon, I promise. These DNS queries are transferred as UDP packets in transport layer. The destination port is 53. This is the IP packet with the source and the destination IP addresses. So we'll go through the layers one by one, and we'll see all these packets, datagrams, and frames in detail. So we'll keep going. This is the structure of the Ethernet frame. First, there are two DNS queries for www.hackeracademy.uk. One for the IPv4 address, and the other one is for the IPv6 address. And because the website is redirected to hackeracademy.uk, there are two more DNS requests for this address. Next, DNS packets are the DNS query responses. This response is type A. That means it's an answer for the IPv4 request. And here's the answer, the IP address of the website. Now, DNS response packet uses UDP at the transport layer, IP at the network layer, etc. Here we have a TCP handshake between Kali and the web server. We'll also see this in detail later on. A SYN packet, a SYN ACK as a reply, and an ACK packet to complete the handshake. This is an HTTP GET request. We learned the IP address of the website, and now the system is ready to receive the web page. HTTP protocol and application layer. Now you can see the headers and the parameters of the request. TCP protocol and transport layer, source port, destination port, flags, etc. IP protocol in network layer. Here are the source and destination addresses. And Ethernet frame in layer 2. These are the TCP packets, which will build the HTTP response. So in this example, it's the web page. In other words, the response is transferred between the web server and our system as fragmented packets in transport layer. Here's the HTTP response, 200, okay. So the web page is received. And here's the data, which is our web page. These are the response details, response type, headers, etc. Here there's additional information produced by Wireshark, which says that the HTTP response is created by reassembling 5 TCP segments or packets. So now I'd like to show you the difference between that and HTTPS traffic. So I'll go to the browser and visit an HTTPS page now. But before visiting the page, let's start Wireshark. Here's the start button. Continue without saving. Okay, now we have a clean sheet. So I'll go to the browser and hit enter. Wow, lots of packets in milliseconds. So we've got plenty of packets to investigate. Just click the Stop button once again. Okay, so the DNS request and the response packets first. Here is a response with an IPv4 address. Here there's a TCP three-way handshake between Kali and port 443 of Google's web server. And now a client hello TLS packet to start the TLS handshake, again between Kali and Google's server. Now to get rid of the other traffic records, I'd like to filter the results by the IP address of the Google server. Now, while the mouse pointer is on the server IP address, right-click and go to Apply as Filter and select the Selected option. So as you can see here in the filter bar, the IP address is assigned as the destination IP address. Now, we only have to see the traffic where the destination is the Google server. But we'd like to see both the incoming and the outgoing traffic. So I'll change the DST part of the filter to ADDR and click the blue arrow to activate the new filter. Now we can see the traffic in both directions. Okay, so here we are at the Hello TLS message. Here are the details of the message. TLS uses TCP protocol in transport layer. The Google server replies a server hello message as the second step of the TLS handshake. Then comes the certificate and server key exchange, and the server hello done message is sent by the server. Kali sends the client key exchange, Google server sends the new session ticket, and the encrypted communication starts. Here is some encrypted application data, which is meaningless for others who listen to the traffic. And as you can see here, the message is encrypted at the application layer, so you can still see the source and the destination addresses, the ports, etc. This is how an IPv4 packet is seen on Wireshark. So it's a DNS query response. The fields we mentioned are seen pretty clearly. Version is 4. Header length is 5 words, which means no options field. Total length is 96 bytes. MF and DF flags are not set. And you can see the source and the destination addresses and all the rest. So let's have a look at some of the packets in detail, and we'll analyze them with Wireshark. So for this, I want you to open up the terminal screen, and we'll first check the mode of the Wi-Fi adapter, and sure enough, it is on monitor mode. Now let's run Wireshark with root privileges. Now before capturing any traffic, we need to select a network interface on this list. So let's select WLAN 0MON and click on the Capture button. All right, so now Wireshark is listening to network traffic. As you can see, there are lots of beacon frames, probe requests, and probe responses between the different sources and destinations. So we'll stop the capturing and we'll look at the details of the packets. So in this section, there's time, source, destination, protocol length, and detailed information about the packet. In the middle of the screen here, there's detailed information for a specific packet. Details about frame and header. As you can see, this is a probe response packet. The frame control field contains the destination address, as well as the transmitter address of this packet. And we can see the SSID in the wireless management field. We can customize the appearance of the results in the preferences under the Edit tab. And you can add a new field if you want to, and that will display in the columns. So here you can select the type of field, and I want to add frequency and channel information. And there's the column that we added. Now, this is one of the most important and widely used features of Wireshark. We can filter the scan results. Otherwise, it's really kind of difficult to find the package that we want to view easily. For example, when we want to list the packets related to a specific access point, we can use this filter just by giving the SSID name of the access point. Click on this button. Now, all the packets that belong to this access point, called Hacker Academy, are here. In addition, we can also filter by selecting any parameters. So select any information there, right-click on it, and now you can click Apply as Filter and select. All right, so I filtered the management packets. Now let's display only beacon frames. If you want to, you can select two filters, and you can always do this with the AND selected option. As you can see, it's added to this line with the AND parameter. All right, so now I'm listing beacon frames sending broadcast signals. And I'll add another filter to display packets related to Hacker Academy. So Wireshark has many different filters. According to the result that you want to see, you can find the most suitable filter, even on the internet. I'd also like to show you some of the control management and data packets that I mentioned in the previous lecture. For example, we can see the request to send packets using subtype number 27. RTS and CTS are control packets, and they're the optional mechanisms to reduce frame collisions. The subtype number of CTS packets, 28. So let's change the filter with this number, and there's only one CTS packet here. Cool, so let's have a look at the other types of packets now. You might not be able to see all packet types in your scan results. So to analyze packet types, let's download the sample captures just right from the internet. Just type Wireshark sample captures and click on Wireshark's website. And there are lots of different examples of sample captures on this list. So for now, let's find the Wi-Fi captures and select one of the capture files here. All right, so go to Wireshark and we'll close this scan. Open up the downloaded capture file. All right, so let's have a look at the packets in this file. And there are some authentication packets here. And these are the details of this packet. And as you see, the subtype number is 11. So we can use this filter to see only the authentication packet. You can also see the details about the packets by double-clicking on it. So finally, let's have a look at the data packet with subtype 32. Now look, in the middle part, we can see the transmitted data in encrypted form in the data section. HTTP traffic. HTTP, or Hypertext Transfer Protocol, is a commonly used port for the World Wide Web and used by some websites. However, its encrypted counterpart, HTTPS, is more common, which we will discuss in the next. HTTP is used to send, get, and post requests to a web server in order to receive things like web pages. Knowing how to analyze HTTP can be helpful to quickly spot things like SQLi, web shells, and other web-related attack vectors. HTTP traffic overview. You should already have a general understanding of how HTTP works before completing this lecture. HTTP is one of the most straightforward protocols for packet analysis. The protocol is straight to the point. We can see a sample HTTP packet. Looking at an HTTP packet, we can easily gather information since the data stream is not encrypted like the HTTP counterpart, HTTPS. Some of the important information we can gather from the packet is the request URI, file, data, and server. Now that we understand the basic structure of an HTTP packet, we can move on to looking at a sample HTTP packet capture to get hands-on with the packets. Practical HTTP packet analysis. To get an understanding of the flow of HTTP packets and get hands-on with the packets, we analyze the http.cap file. After opening the PCAP, we can see that this is just a simple HTTP packet capture with a few requests. Navigating deeper into the packet capture, we can look at the details of one of the HTTP requests. From this packet, we can identify some very important information like the host, user agent, requested URI, and response. We can use some of Wireshark's built-in features to help digest all of this data and organize it for further future analysis. We can begin by looking at a very useful feature in Wireshark to organize the protocols present in a capture the protocol hierarchy. Navigate to Statistics Protocol Hierarchy. This information can be very useful in practical applications like threat hunting to identify discrepancies in packet captures. The next feature in Wireshark we will look at is the Export HTTP object. This feature will allow us to organize all requested URI in the capture. To use Export HTTP object, navigate to File, Export Objects, HTTP. Similar to the protocol hierarchy, this can be useful to quickly identify possible discrepancies in capture. The last feature we will cover in this section of this lecture is endpoints. This feature allows the user to organize all endpoints and IPs found within a specific capture. Just like the other features, this can be useful to identify where a discrepancy is originating from. To use the endpoints feature, navigate to Statistics Endpoint. HTTP is not a common protocol to see too much as HTTPS is now more commonly used. However, HTTP is still used often and can be very easy to analyze if given the opportunity. Now, HTTPS consists of communication over HTTP within a connection encrypted by TLS, Transport Layer Security, or its predecessor, SSL, the Secure Sockets Layer. The main motivation for HTTPS is authentication of the visited website and protection of the privacy and integrity of the exchanged data. So let's see how a typical encrypted connection between the server and the client is established. The client sends the information that the server needs to communicate with the client using SSL. This information contains the client's SSL version number, cipher settings, and session-specific data. The server then sends the information that the client needs to communicate with the server over SSL. The server also sends its own certificate. The client uses the information sent by the server to authenticate the server. So using all data generated in the handshake thus far, the client creates the pre-master secret for the session, encrypts it with the server's public key, and then sends the encrypted pre-master secret to the server. The server uses its private key to decrypt the pre-master secret, and both the client and the server perform a series of steps to generate the master secret. Then, they use the master secret to generate the session keys, which are symmetric keys used to encrypt and decrypt information exchanged during the SSL session and to verify its integrity. The client sends a separate message indicating that the client portion of the handshake is finished, and the server sends a separate message indicating that the server portion of the handshake is finished. And then another thing in a policy is to identify how many passwords are transmitted. So even by having a strong password, if it's not carried securely, it can be exposed. So while transmitting a password, the application should use encryption. And this is, of course, HTTPS. But not only passwords, but any other sensitive data, such as payment information. So this brings us to yet another problem that we're going to cover in session management. HTTPS shouldn't only be used on login pages, but the entire application. So go to Kali and open up your terminal. And we're going to capture network traffic to watch for credentials that are transmitted. So open up Wireshark by typing, and then open up your browser. I'm going to just dock it over here to the right side and go to the BWAP login page. Now, before you log into BWAP, start capturing the traffic on your network interface. So in my case, it is ETH1. So I'll choose it and start a capture by clicking this icon on the toolbar. And then go to the login page. Enter username and password, hit login button. Okay, so we logged in. So now let's go to Wireshark. Now, here's a place that you apply display filters on the capture traffic. So simply type HTTP to view HTTP traffic. As you can see, the first line is the login request that we sent. Click it to choose, and below you can display details about this line. So under this node, there are HTTP-related data. And under this node, you will see the form data has been entered. And you can see it is in clear text. So anyone on the same network can sniff this data. You can also right-click on this line and follow the TCP stream, and then view the HTTP traffic data as we see it in Burp. Okay, so now I'm going to close this window and stop capturing. Let's return to the browser again. This time, go to an HTTPS web application, and I'll just open the Twitter login page. And I'll get me a fresh capture. Okay, so enter in some login information here and log in. And you see Wireshark again is capturing the traffic. But this is not raw HTTP. It is encrypted traffic. So I'm going to filter SSL only traffic. And you can see the protocol. It is TLS version 1.2. So this means the data is encrypted. Choose any line, and from the below pane, open Secure Socket Layer node, and here is the encrypted application data sent over the network. So if you follow TCP stream, you won't see anything. So obviously the point here is, as a pen tester, we need to check if the application data is sent over a secure channel or not. All right? So now we need to report, and we can benefit from this finding as well.
DNS traffic. DNS overview. DNS, or Domain Name Service Protocol, is used to resolve names with IP addresses. Just like the other protocols, you should be familiar with DNS. There are a couple of things outlined below that you should keep in the back of your mind when analyzing DNS packet. Query response. DNS servers only. UDP. If any one of these is out of place, then the packets should be looked at further and should be considered suspicious. We can see a packet capture with multiple DNS queries and responses. Instantly looking at the packets, we can see what they are querying. This can be useful when you have many packets and need to identify suspicious or unusual traffic quickly. DNS traffic overview. DNS query. Looking at the below query, we really have two bits of information that we can use to analyze the packet. The first bit of information we can look at is where the query is originating from. In this case, it is UDP 53, which means that this packet passes that check. If it was TCP 53, then it should be considered suspicious traffic and needs to be analyzed further. We can also look at what it is querying as well. This can be useful with other information to build a story of what happened. When analyzing DNS packets, you really need to understand your environment and whether or not the traffic would be considered normal within your environment. DNS response. Below we see a response packet. It is similar to the query packet, but it includes an answer as well, which can be used to verify the query.
Hello, my friends. We're going to analyze the ARP protocol with Try Hack Me Wireshark. So let's go ahead and observe a few more of the detailed results. From the IP address of 10.10.159.142, our very own computer, let's send 5 ping messages to a computer with an IP address of 10.10.136.117. It's going to be a different computer on this same network. All right, so let's type in the command prompt. The MAC address of the target computer is going to be required for communication. And because the source cannot send an ICMP message without the destination's device's MAC address, we will first need to press the Wireshark start button and listen out for it. So we'll type ping-c5 10.10.136.117 right here in the command prompt and press enter. So it'll return 5 pings, and we can stop listening with the Wireshark stop button. All right, so we see the results of the 5 ping messages in the command prompt window. Ping results are listed with a lot of detail. The timings of the 5 ping messages can be examined and compared as well. What we're going to do is analyze this traffic with Wireshark. So we made Wireshark full screen here. And let's make an ARP filter from within the network traffic. So when we make an ARP filter, we see 2 ARPs in protocols 1821 and 1822. The IP address of our computer is 10.10.159.142, but who are we pinging? 10.10.136.117. So the MAC address of this IP address is being asked for with ARP, my friends, you see, and it does indeed broadcast, just like we were talking about earlier. It also has its destination here. Broadcast is written as the destination, right? It actually broadcasts to the whole network. It says the protocol is ARP, and here the MAC addresses are written. Yeah. So it already starts with numbers 0 and 2, so 2 computers on the same local network. So traffic MAC address 1821 is our computer's MAC address, 02545E7186A5. And the traffic numbered 1822 is the MAC address of the destination computer, 10.10.136.117 IP address, and the MAC address 028C34F0B5DD. So why don't we just examine here in the package details section, 1821 ARP request and the 1822 ARP reply. So let's have a look at the first one from 1821, my friends. Here we've got Ethernet 2. The MAC address of the source in layer 2 is 02545E7186A5. The source address is 10.10.159.142. Just happens to be the address of our computer. Now, if the destination MAC address is the highest 48-bit MAC address, the highest value is FFFFFFFF, right? With the largest number you know is the hexadecimal F, that is the highest value, and it's written MAC. So it already has been given in detail in Ethernet 2 line here. Distribution broadcast, FFFFFFFFFF. Now let's have a look at the ARP request content in detail. So here's our IPv4 address, opcode equals 1. And in the answer, we will see that it is 2. So this is also an important issue here, right? So here's the sender's IP address. That is the part that belongs to our computer. Okay, the target is 10.10.136.117. That's the IP address. The MAC address is empty. 000000000000. Now, why is it empty? Yeah, we don't know the ARP request already. That's why it's empty. Good guess if you were guessing. Anyway, let's click on the reply, traffic number 1822. And what does that say? Well, let's have a look. We're looking at the details of the address resolution protocol reply. And this time, the sender and destination have changed places. Also, this has changed, right? Opcode equals 2. Now, since the reply came from the other computer, the location of the sender and the target has changed as well. That makes sense. Sender IP address 10.10.136.117. The sender MAC address 028C34F0B5DD. So the target was back to our computer 10.10.159.142, which is the IP address. And of course, our destination MAC address is 0254-5E7186A5. So how does it actually know? Well, because in the ARP request, we sent our MAC address. It has saved our MAC address in the ARP table. Now, this in return, the reply doesn't have to be broadcast, right? It's unicast because the destination MAC address is known. So we received the ARP request response, sent the MAC address of 10.10.136.117, and ARP is now finished. Now let's have a look at a graphical representation of the ARP traffic, my friends. So we'll choose the Statistics Flow Graph menu, and the graphic display, as you can see. So we can choose Limit to Display Filter, and ARP traffic will fill the screen. Now look at this. If you remember, 02545E7186A5 is the MAC address of our computer. So what are we actually asking? The MAC address of 10.10.136.117. So see, it's first broadcast. So we see the broadcast. And here the target is the full network. Of course, who the reply comes from, the computer with the IP address of 10.10.136.117. And other computers or other devices in the network need not reply, and so they don't take any action. Now here too, first line in the comments, 10.10.136.117. Who are you? 10.10.159.142 is asking. So the reply comes from the computer with the address, the IP address of 10.10.136.117 in the second comment line. And it writes its own MAC address, 028C34F0B5DD, and sends it in the reply. So you see that the graph is actually a great way to have a look. It's well illustrated by the arrows in the request and the reply. Broadcast in the middle because, well, the request doesn't actually know the direct MAC address, so it has to send it out throughout the network, and the reply is unicast as long as the destination MAC is known. So directly from this MAC to MAC. Okay, so source MAC address is known, destination MAC address is known, and the graphics are already MAC address based. So these arrows point to the MAC addresses, and it already works with layer 2 MAC addresses. Switches find direction with the MAC address. So let's close up this graph window and let's see where are our pings. Now 1821, 1822 ARP. So I couldn't see ICMP. So we'll do an ICMP filter. And sure enough, ICMP was able to start in 1823. And it was sent from 10.10.159.142 to 10.10.136.117 from our computer. And how many messages? 5 units. See requests and replies. So where were the ARP packets? 1821 and 1822 numbers in the ARP. So let's see it all together. Okay, so look at this. The ARP is here. ICMP will be possible after the ARP is done. It's not possible otherwise, you remember. So in other words, you cannot send data on a local network without knowing the MAC addresses. All right. It's just not possible, and that's a good thing, my friends. All right, so there's just about everything you need to know about ARP. We can wrap it up here. I'll see you next time.
ICMP traffic, ICMP overview. ICMP, or Internet Control Message Protocol, is used to analyze various nodes on a network. This is most commonly used with utilities like ping and traceroute. You should already be familiar with how ICMP works. You can see a sample of what a ping would look like. We can see a request to the server from ICMP, then a reply from the server, ICMP traffic overview, ICMP request. We see packet details for a ping request packet. There are a few important things within the packet details that we can take note of, first being the type and code of the packet. A type that equals 8 means that it is a request packet. If it is equal to 0, it is a reply packet. When these codes are altered or do not seem correct, that is typically a sign of suspicious activity. There are 2 other details within the packet that are useful to analyze: timestamp and data. The timestamp can be useful for identifying the time the ping was requested. It can also be useful to identify suspicious activity in some cases. We can also look at the data string, which will typically just be a random data string. ICMP reply. You can see that the reply packet is very similar to the request packet. One of the main differences that distinguishes a reply packet is the code. In this case, you can see it is 0, confirming that it is a reply packet. The same analysis techniques for request packets apply here as well. Again, the main difference will be the packet type.
So what is FTP? FTP is File Transfer Protocol. It's a network protocol for transmitting files between computers over Transmission Control Protocol Internet Protocol, also known as TCP/IP, connections. So within the TCP/IP suite, FTP is considered an application layer protocol. In an FTP transaction, the end user's computer is typically called a local host. The second computer involved in FTP is the remote host, which is usually a server. Both computers need to be connected via a network and configured properly to be able to transfer files via FTP. Now, servers must be set up to run FTP services, and the client must have FTP software installed to access these services. Although many file transfers can be conducted using Hypertext Transfer Protocol, or HTTP, which is yet another protocol in the TCP/IP suite, FTP is still commonly used to transfer files behind the scenes for other applications, such as banking services. It's also sometimes used to download new applications via web browsers. So how do you imagine FTP to work? Well, FTP, like I said, is a client-server protocol that relies on 2 communications channels between the client and server: a command channel for controlling the conversation and a data channel for transmitting the file content. So here's how a typical FTP transfer works. 1. A user typically needs to log on to the FTP server, although some servers make some or all of their content available without a login, a model known as anonymous FTP. 2. The client initiates a conversation with the server when the user requests to download a file. 3. Using FTP, a client can upload, download, delete, rename, move, and copy files on a server. Now, FTP sessions work in active or passive modes. In active mode, after a client initiates a session via a command channel request, the server creates a data connection back to the client and begins transferring data. In passive mode, the server uses the command channel to send the client the information it needs to open a data channel. Because passive mode has a client initiating all connections, it works really well across firewalls and network address translation gateways. Users can work with FTP via a simple command line interface from a console or terminal window in Microsoft Windows, Apple, macOS, or Linux, or with a dedicated graphical user interface. Web browsers can even also serve as FTP clients. So then why would FTP be important? And what's it used for, really? Well, FTP is a standard network protocol that can enable expansive file transfer capabilities across IP networks. Without FTP, File and data transfer can be managed with other mechanisms, such as email or an HTTP web service, but those other options lack the clarity of focus, precision, and control that FTP enables. So FTP is used for file transfers between one system and another, and it has several common use cases, including the following. Backup. FTP can be used by backup services or individual users to back up data from one location to a secured backup server running FTP services. It can be used in replication, which is similar to backup, but replication involves duplication of data from one system to another, but takes a more comprehensive approach to provide higher availability and resilience. FTP can also be used to facilitate this. Access and data loading. FTP is also commonly used to access shared web hosting and cloud services as a mechanism to load data onto a remote system. Now, there are a few different types of FTP. In fact, there are several different ways that an FTP server and client software can conduct a file transfer using FTP. Anonymous FTP, which I mentioned before, it's the most basic form of FTP, but it provides support for data transfers without encrypting data or using a username and password. It's most commonly used for downloading of material that's allowed for unrestricted distribution. It will work on a port. We've got password-protected FTP. And this is also a basic FTP service, but it requires the use of a username and password. Though the service might not be encrypted or secure, it will work on port 21. See, now we've got FTP Secure, or FTPS, and that's sometimes referred to as FTP Secure Sockets Layer, FTP SSL. Now, this approach enables implicit transport layer security, TLS, as soon as an FTP connection gets established. FTPS was initially used to help enable a more secure form of FTP data transfer, so it typically defaults to using port 990. FTP over explicit SSL TLS, or FTP PES. So this approach enables explicit TLS support by upgrading an FTP connection over port 21 to an encrypted connection. So this is a commonly used approach by web and file sharing services to enable secure file transfers. Speaking of which, Secure FTP, or SFTP, is technically not an FTP protocol, but it functions rather similarly. In fact, SFTP is a subset of the Secure Shell, or SSH protocol, that runs over port 22. Now, SSH, of course, is commonly used by system administrators to remotely and securely access systems and applications, and SFTP provides a mechanism within SSH for secure file transfer. So what is TFTP? Well, TFTP is also known as Trivial File Transfer Protocol. It's a simple protocol that's used for sending a file from the server to the client. So Trivial File Transfer Protocol just uses the concept of UDP to share files between server and client. So here, UDP stands for User Datagram Protocol. So TFTP, Trivial File Transfer Protocol, has a very simple concept. And due to this simple concept, it's pretty much a straightforward design as well. Although, due to its simple design, it has limited features when compared to File Transfer Protocol. In general, Trivial File Transfer Protocol does not follow any authentication before the communication of a file. So Trivial File Transfer Protocol does not apply any security mechanism while filing communication. So since Trivial File Transfer Protocol does not follow any authentication mechanism or any security mechanism, it really could not be used over the internet to communicate files. Hopefully that's obvious. It's generally used for communicating files among machines set up in the average local intranet only. Trivial File Transfer Protocol's most important feature, though, is that it uses a minimal amount of memory. Trivial File Transfer Protocol could actually be used to communicate boot files if computers do not have hard disks. Trivial File Transfer Protocol generally uses port 69. However, the port used for communication could also be defined when Trivial File Transfer Protocol is being set up. Okay, then, so what is TFTP used for? Well, Trivial File Transfer Protocol, or TFTP, is used for communicating files between client and servers within a local network. So, Trivial File Transfer Protocol is definitely beneficial when the client computer has very low memory, storage devices, or hard disk devices. It could be used to communicate boot files when the server is on the client's computer. Since it's easier to implement, well, it could widely be used when we have a low security mechanism to be followed. It doesn't really follow any authentication mechanism, so that means only those files can be communicated, which doesn't necessarily have to meet any security procedure. So then, how does it work? Well, first we got to understand how TFTP works. First, we'll look at the mechanism of how does communication take place between a client and server. So here, since Trivial File Transfer Protocol uses UDP for communicating files, it establishes a connection, generally by using port 69. Then once a connection is established, the client generally requests RRQ or WRQ. So here, RRQ means read request, and WRQ stands for write request. So a client will generally request reading requests if it wants to only read the file, and then generate a written request if they want to write a particular file that exists on the server. So once that's done, then files can be communicated in the form of small packets. When I say small, I mean 512 bytes. So the file to be communicated is divided into these small packets, where each packet consists of 512 bytes. Now, once a packet is communicated from server to client, the server waits to receive an acknowledgement from the client that the packet has been received. Once the acknowledgement is received, the server sends the next packet of 512 bytes. And of course, this goes back and forth until the last packet is communicated from the server side to the client side. Now, how about a brief look at some of the scenarios while communicating data packets? So what would happen if a packet is not received on the client side? Well, that's a good question, because when a packet is communicated from server to client, the server starts a timer. It'll wait until this time to receive the acknowledgement from the client side. If the acknowledgement is not received from the client side, then the server resends the same packet until its acknowledgement is received. However, if acknowledgement is received before the timer, then it can go ahead and send the next packet. So then, how will the client know that file communicating is done? I'm glad you asked, because the last packet which is generated for sharing a particular file is always less than 512 bytes. So even if the packets generated are multiples of 512, then it sends an additional packet which is fewer than 512 bytes, so that the client could understand that it has received the final file. Now, there are different types of TFTP, and generally TFTP is divided into 4 different types: read request, write request, data packet, and acknowledgement request. Are there any advantages to TFTP? Well, sure enough, uses UDP protocol. It's easier to implement, requires a lot less coding, and there's less memory usage. All right, so why should we use TFTP and why do we need TFTP? Well, we could use TFTP because of the following reasons. Since it requires less memory, I think those would be obvious advantages. Since it requires less coding, that opens it up to a variety of different users, less skilled in code. It follows the concept of UDP, so it's easily implemented. And it's certainly a lot easier to communicate a file. Now, we need TFTP because communicating files between servers and clients. And with no authentication, this makes the communication of files very easy. All right, so that's the lesson up till now. That's pretty cool, huh? We learned SNMP, we went over syslog, FTP, and TFTP. You really did learn a lot. I'll tell you what, I'm sure you didn't get bored because this is crazy stuff. And I know that you're going to put it to good use. So with that said, I want to see you in our next lesson. Thank you for hanging in. All right, my friends, welcome back. So we have to first define what is web pen testing. Now, you also might know it as web application penetration testing, but it's basically a systematic process of evaluating the security of web applications by identifying and exploiting any vulnerabilities. So we're aiming to uncover potential weaknesses that malicious actors could exploit to compromise the confidentiality, integrity, or availability of the application and any of its data. All right, so now let's have a look at the key components of web pen testing, which are understanding web applications, attack surface analysis, threat modeling, testing methodologies, and stages of web pen testing. So now let's have a look at each of these one at a time. First up, understanding web applications. So web pen testers need a deeper understanding of how web applications function, including the technologies, frameworks, and protocols that they use. This understanding helps identify potential entry points such as input fields, authentication mechanisms, as well as data processing functions. Which brings us to attack surface analysis. So pen testers analyze the attack surface of web applications to identify all entry points accessible to potential attackers. So this includes examining the application's endpoints, APIs, authentication mechanisms, as well as data storage systems. Then third up, we've got threat modeling. Pen testers conduct threat modeling exercises to anticipate potential threats and prioritize security testing efforts. And by identifying likely attack scenarios and their potential impact, pen testers can tailor their testing strategies to focus on the most critical areas. Then we've got testing methodologies. Yeah, because web pen testing employs a variety of testing methodologies, including what they call black box testing or white box testing. There's even gray box testing. But black box testing basically simulates attacks from an external perspective, while white box testing involves analyzing the application's internal code and architecture. Gray box testing combines the elements of both. All right, so now we're ready to have a look at these stages of web pen testing. Target identification and information gathering. So pen testers identify the target web application and then gather information about its architecture, the technologies that are used, as well as potential vulnerabilities. The stage may involve reconnaissance techniques like footprinting, DNS enumeration, and web crawling. Vulnerability scanning and analysis. So pen testers can use automated scanning tools, as well as manual testing techniques to identify commonly known vulnerabilities such as SQL injection, cross-site scripting, better known as XSS, insecure authentication mechanisms, and insecure direct object references, or IDOR. Vulnerability scanners help to identify known vulnerabilities, while manual analysis uncovers complex or unique issues that automated tools might actually miss. So once vulnerabilities are identified, pen testers attempt to exploit them to gain unauthorized access or escalate privileges within that application. This may involve crafting malicious payloads, exploiting misconfigurations, or even bypassing security controls to achieve their objectives. Pen testers will document their findings in a comprehensive report detailing discovered vulnerabilities, their potential impact, as well as their recommended remediation steps. So the report is shared with a development team or system administrators that are responsible for addressing the identified issues. The remediation efforts aim to patch or mitigate vulnerabilities, improve security controls, as well as strengthen the overall security posture of that particular web application. Well, now that you know about the importance of web pen testing and its importance, we'll wrap it up here, and then when we come back in the next videos, we'll see some web pen testing tools, as well as what the heck is bug bounty, as well as some popular bug bounty sites. All right, so I'll see you next video. Well, hello there, welcome back. Today, we are going to dive deep into the world of web pen testing tools, and I hope you're as excited as I am. Check out the screen in front of you here. We're going to explore some of the most popular and widely used tools that security professionals rely on to assess the security posture of different web applications. Now, when it comes to web application security testing, having the right tools at your disposal can make all the difference. So these tools empower security professionals, often referred to as pen testers, to identify vulnerabilities, analyze potential attack vectors, and ultimately secure web applications against malicious exploitation. So, without any further ado, let's embark on a journey through the fascinating realm of web pen testing tools. From comprehensive suites to specialized scanners and brute-forcing utilities, we're going to cover a wide range of tools designed to meet the diverse needs of pen testers. Then by the end of this video, you'll have a solid understanding of the capabilities and the functionalities of these tools, as well as their role in the larger context of web application security testing. So, buckle up and let's jump in and explore the exciting world of web pen testing tools together. Well, let's get started with Burp Suite. So Burp Suite, it's a powerful web application security testing toolkit that's widely used by pen testers. It provides a wide range of features for intercepting, manipulating, and analyzing HTTP traffic. A few key modules include Proxy, which allows interception and modification of HTTP requests and responses, a Scanner, which automatically scans web applications for security vulnerabilities, an Intruder, which facilitates automated attacks such as brute force, fuzzing, and parameter manipulation. It also has a Repeater, and this enables manual manipulation and resending of individual requests for testing. Decoder. This supports decoding and encoding of various data formats used in web applications. Burp Suite's extensibility through plugins also makes it highly versatile, as well as customizable for different testing scenarios. So Burp Suite is fantastic, has a wide range of tools and features, but we're going to take a deeper dive into Burp Suite a little bit later. I want to show you some other tools first, because we cannot forget about OWASP ZAP. That stands for Z Attack Proxy. So OWASP ZAP is actually a free and open source alternative to Burp Suite, offering a similar functionality for web application security testing. It features both automated and manual scanning capabilities, including passive and active scanning modes. OWASP Zap supports features like automated spidering, fuzzing, and session management, making it suitable for a wide range of testing scenarios. Then we've got Nikto. So Nikto is a command-line web server scanner designed to identify vulnerabilities as well as misconfigurations in web servers. It scans for over 6,700 potentially dangerous files and programs, checks for outdated server software, and identifies version-specific vulnerabilities. Nikto is also particularly useful for detecting common issues like outdated software versions, insecure configurations, and known vulnerabilities in web servers. Which leads us to Nmap, Network Mapper. So Nmap is primarily a network scanning tool, but it's also got some valuable purpose for web application reconnaissance. It can identify open ports, services, and technologies used by web servers, providing valuable information for assessing their security posture. Nmap's scripting engine allows for custom scripts to automate tasks like service version detection and vulnerability scanning, enhancing its utility in web pen testing. But we've also got SQLmap. So SQLmap is a specialized tool for detecting and exploiting, guess what? SQL injection vulnerabilities in web applications. Yeah, they're still out there. It automates the process of identifying SQL injection points, extracting data from databases, as well as escalating privileges through SQL injection attacks. SQLmap supports various database management systems and offers advanced features like tampering, fingerprinting, and password hashing during exploitation. Another couple of favorites are Derb and WFuzz. Derb is a web content scanner and directory brute forcing tool, and it gets used for discovering hidden files and directories on web servers. WFuzz, or WFuzz, as some people say, is a web application password cracker, and this can be used for brute forcing login pages, forms, and other web application parameters. But you see, both tools are commonly used for reconnaissance and enumeration during web application pen testing, and that helps you identify additional attack surfaces as well as any other potential vulnerabilities. Now, while we've covered a range of powerful tools, it really is important to note that web penetration testing is a dynamic and evolving field, because there are going to be new tools and techniques emerging regularly. And as you continue your journey in cybersecurity and web application security testing, I definitely encourage you to explore additional tools beyond the ones that we've discussed today. So each tool is going to bring its own unique capabilities and advantages, and mastering a diverse toolkit will enhance your effectiveness as a pen tester. So you got to remember, the key to successful web application security testing lies not only in the tools you use, but also in your understanding of attack methodologies, best practices, and the ever-changing threat landscape. So in other words, you got to keep learning, keep experimenting, and honing your skills to stay ahead of the curve, because this is an exciting and challenging field. So yeah, we have now explored the importance of web pen testing and introduced several essential tools used in the process, including GUI-based and command-line tools. So these tools provide pen testers with the capabilities to identify, exploit, and remediate security vulnerabilities effectively in web applications. When we come back in the next video, we're going to delve into bug bounty programs and a few popular bug bounty sites. I'll see you then. And we're back. We're going to explore the various tabs within Burp Suite and also understand their functionalities. But first, we'll cover the basics. Yeah, so we're going to delve into the fundamental basics of Burp Suite. We'll cover the installation on different platforms, basic configuration settings, initial setup. Once you understand these basics, well, you're going to have a very smooth experience with Burp Suite throughout the rest of the course. First up is a dashboard. You see the dashboard tab serves as a central hub for monitoring and managing your testing activities. Now here you can actually view in real time updates on intercepted requests, responses, as well as any security issues detected during your testing session. Additionally, you might want to customize the layout and the widgets to suit your preferences and workflow. And as you can see, the dashboard is structured quite well. And here we can see the sites that we visited, the requests we've made, different tasks we've done, configurations, other developments. And here's our log section, right? So it's all here in the dashboard. Let's move on over to the Target tab. So this Target tab is where you define and manage the scope of your testing. You can add target applications, specify inclusion and exclusion criteria, as well as configure various settings to tailor your testing environment. So understanding the Target tab is perhaps obvious, but it is essential for effective targeting and scoping of your security assessments. So in our Target section, we have our sitemap under the Target tab, along with the scope and the issue definition sections. And since I've previously added this site to the scope section using the Add button, it's only this site added subdirectories that you can see here in my sitemap section. Moving on to the Proxy tab. So here under the Proxy tab is hiding, but certainly not dormant, a core component of Burp Suite, allowing you to intercept and manipulate HTTP and HTTPS traffic between your browser and the target application. Here you can set up your interception rules, modify requests and responses on the fly, as well as analyze traffic patterns for potential security vulnerabilities. Additionally, configure SSL settings for handling encrypted traffic transparently. All right, so moving on after the Target section, move into the Proxy section. You see, this part can be considered actually the most frequently used area because here's where we perform packet captures. So we turn on Intercept, we enable packet interception, and this allows us to mediate packet flows. Now conversely, when Intercept is off, we actually permit packets to pass through without any interception. So we'll just illustrate here with a simple example. So imagine that we have a website and I navigate to the My Account section. So after turning on Intercept, when I click Login, as you can see, we capture packet and its content. Now, back in the Proxy section here, there are other functionalities available as well. We can observe the methods used to make requests to the visited sites, which URLs were accessed, and so on and so forth. You get the idea. Now, similarly, we can configure WebSocket and proxy settings. And here we can specify which ports and IP addresses Burp Suite should use to differentiate its operations. All right, so let's make some more progress here and go to the Intruder tab. Now, here's where we transition from manual testing to automated attacks. This is a very powerful tool. It enables you to launch customizable attacks against target parameters like usernames, passwords, and input fields using various attack payloads as well as different attack types. You can analyze the responses to identify potential injection points and security vulnerabilities very efficiently right from here. Now, additionally, we can modify our attack patterns and conduct attacks on different targets by changing our attack methods. And we can specify where to inject variables or payloads. All right, so far so good, right? But there's more. What's under the Repeater tab? Well, this provides a sandbox environment for manual testing as well as some experimentation. So here you can resend and modify individual requests in order to observe their impact on the target application in real time. Now, you've got full control over request parameters and can analyze server responses to understand application behavior, as well as identify potential security flaws. Check this out. With a Sequencer tab, we actually shift our focus to analyzing the randomness and predictability of tokens and session identifiers used within the target application. So by capturing and analyzing sample data, you can perform statistical analysis to assess the strength of cryptographic algorithms and identify potential weaknesses in session management mechanisms. All right, let's check out the Decoder tab, because this is going to offer a suite of tools for encoding and decoding data in various formats commonly encountered during web security testing. So here you can decode URL-encoded strings, base64 encoded data, as well as other encode formats, as well as encode data for payload manipulation and evasion techniques. We'll get to all that soon. But I want to also point out that you can perform hash computations as well as cryptographic operations for data validation and integrity checks. There's even more, though. In the Comparer tab, you can compare two HTTP and HTTPS requests or responses side by side to identify differences, similarities, anomalies. This feature is actually very useful for identifying variations in server responses, also detecting changes in application behavior, and pinpointing security-related issues such as inconsistent input validation or output encoding. Now the Logger tab. So this records all HTTP and HTTPS traffic exchanged between Burp Suite and the target application, providing a comprehensive log of requests, responses, as well as all the associated metadata. You can review logged entries, search for specific requests or responses, and filter traffic based on various criteria. Additionally, you can export logs for further analysis or documentation purposes. Let's see what the Extender tab's for. So this serves as a platform for extending the functionality of Burp Suite through custom plugins, scripts, and integrations. So you can install and manage existing extensions from the BAP store or even develop your own using Burp Extender APIs. So this extensibility is outrageous, right? I mean, it actually allows you to enhance your testing capabilities, automate repetitive tasks, and integrate Burp Suite with other security tools and frameworks seamlessly. That's why you want to get to be an expert, so that you can come in here and write some extensibility. All right. Now that we've completed the walkthrough of the Burp Suite Basics room and the Try Hack Me platform, let's go ahead and solve the Burp Suite room on Try Hack Me. Let's go ahead and solve the Burp Suite room on Try Hack Me. All right. As you can see, the definition of Burp Suite goes like this. Burp Suite is the industry standard tool for web application hacking. It's essential in any web penetration test. This module will cover the basic functionality of the core tools in the Burp Suite framework, that is, proxy, target, repeater, intruder, sequencer, decoder, comparer, and extender. So you're going to learn how to apply Burp Suite when enumerating and attacking realistic web applications, as well as how to approach some of the common scenarios you may encounter when attacking a web app. Just by clicking on the Burp Suite Basic Room. See, once we click on the Burp Suite Basic Room, the page that we encounter has 15 tasks. So let's just start from task 1 and work our way through. Welcome to Burp Suite Basics. So this particular room aims to understand the basics of the Burp Suite Web Application Security Testing Framework. Our focus, of course, will revolve around the following key concepts: a thorough introduction to Burp Suite, a comprehensive overview of the various tools available within the framework, detailed guidance on the process of installing Burp Suite on your system, navigating and configuring Burp Suite to your sweet desire. Now, we'll also introduce the core of the Burp Suite framework. That, my friends, is the Burp Proxy. It is important to note that this room primarily serves as a foundational resource for acquiring knowledge about Burp Suite. Subsequent rooms in the Burp module will adopt a more practical approach. Therefore, this room will contain a greater emphasis on theoretical content. Now, if you haven't ever used Burp Suite before, it's actually recommended to carefully read the provided information and actively engage with the tool a little bit just to, get yourselves acquainted. Okay. Combining the information presented here with the hands-on exploration will establish a very strong foundation for when you get to use the framework on your own. And guess what? It's going to help you in the future as well. All right? So once you click on the Start button, let's move on. So in Task 2, we explore what Burp Suite is. Now, in essence, Burp Suite is a Java-based framework, and it's designed to serve as a comprehensive solution for conducting web application penetration testing. It's actually become the industry standard tool for hands-on security assessments of web and mobile applications, including those that don't rely on application programming interfaces, otherwise known as APIs. So if you ask me to put it simply, Burp Suite captures and enables manipulation of all of the HTTP and HTTPS traffic between a browser and a web server. This fundamental capability forms the backbone of the framework. By intercepting requests, users have the flexibility to route them to various components within the Burp Suite framework, which we'll actually explore in some of the upcoming sections. Don't worry about that yet. But the ability to intercept, view, and modify web requests before they reach the target server, or even manipulate responses before they get received by the browser, makes Burp Suite an invaluable tool for manual web application testing. So Burp Suite is actually available in different editions. For our purposes, we're just going to be focusing on the Burp Suite Community Edition. It's freely accessible for non-commercial use within legal boundaries. However, it's worth noting that Burp Suite also offers Professional and Enterprise editions. These are going to come with advanced features and require licensing. Burp Suite Professional is an unrestricted version of Burp Suite Community. So it's going to come with a few extras, such as an automated vulnerability scanner, a fuzzer brute forcer that isn't rate limited, saving projects for future use and report generation, a built-in API to allow integration with other tools, unrestricted access to new extensions for greater functionality, as well as access to the Burp Suite Collaborator, and this effectively provides a unique request catcher self-hosted or running on a Portswigger-owned server. So in short, Burp Suite Pro is a highly potent tool, making it a preferred choice for, guess what, professionals in the field. But hey, it's all right, you're just learning. Burp Suite Enterprise, I'll tell you a little bit about too, in contrast to the community and professional editions, is, guess what, primarily utilized for continuous scanning. It features an automated scanner that periodically scans web applications for vulnerabilities, very similar to how tools like Nessus perform automated infrastructure scanning. Now, unlike the other editions, which allow manual attacks from a local machine, Burp Suite Enterprise resides on a server and constantly scans the target web applications for potential vulnerabilities. So, of course, due to requiring a license for the Professional and Enterprise editions, we're going to focus on the core feature set provided by Burp Suite CE or Community Edition. Do want to make a note here that the provided demonstrations utilize Burp Suite for Windows. However, the functionality remains consistent with the version installed on the attack box. So, you ready for the question and answer section? First one is, which edition of Burp Suite runs on a server and provides constant scanning for target web apps? Just told you, right? The answer, of course, should be Burp Suite Enterprise. Number 2, Burp Suite is frequently used when attacking web applications and applications. That's right, the answer should be mobile. Moving on to task 3, my friends. Here's where we explore the features of Burp Suite Community. Now, you already know that Burp Suite Community offers a limited feature set compared to the Pro Edition, but it still provides an impressive array of tools that are highly valuable for web application testing. That's why I want to walk you through some of these key features. Proxy. So we've got the Burp Proxy. This is the most renowned, if you will, aspect of Burp Suite. So it enables interception and modification of requests and responses while interacting with web applications. Another well-known feature, Repeater. So Repeater allows for capturing, modifying, and resending the same request multiple times. This functionality is particularly useful when crafting payloads through trial and error. For instance, in SQLi, structured query language injection, or testing the functionality of an endpoint for vulnerabilities. Which brings us to Intruder. And despite rate limitations in Burp Suite Community, Intruder allows for spraying endpoints with requests. It's commonly utilized for brute force attacks or fuzzing endpoints. Decoder offers a valuable service for data transformation. It can decode captured information or encode payloads before sending them to the target. While alternative services exist for this purpose, leveraging Decoder within Burp Suite can be highly efficient. Now, just as the name suggests, Comparer enables a comparison of two pieces of data at either the word or byte level. While not exclusive to Burp Suite, the ability to send potentially large data segments directly to a comparison tool with a single keyboard shortcut significantly accelerates the process. And the sequencer, the sequencer is typically employed when assessing the randomness of tokens, such as a session cookie value or, other supposedly randomly generated data. If the algorithm used for generating these values lacks secure randomness, that's going to expose avenues for some pretty devastating attacks, in fact. More on that later. Now, beyond these built-in features, the Java codebase of Burp Suite facilitates the development of extensions to enhance a framework's functionality. Now, these extensions can be written in Java, in Python, using the Java Jython interpreter, or Ruby. In fact, you can also use a Java JRuby interpreter. The Burp Suite extender module is going to allow for quick and easy loading of extensions into the framework. Now, while the marketplace known as the BAP Store enables downloading of third-party modules, I think you want to get started on writing some of your own. And of course, you've got the certain extensions may require a professional license for integration. You've still got a considerable number of extensions available for Burp Community Edition. For instance, have a look at Logger++. It's a module that can extend the built-in logging functionality of Burp Suite. How about a question and answer section? So number 1, which Burp Suite feature allows us to intercept requests between ourselves and the target? Of course, the answer should be proxy. You don't need to think that hard on it, right? Number 2, which Burp tool would we use to brute force a login form? And the answer should be the Intruder tab. Moving on to task 4. So here we learn all about installing Burp Suite on different platforms. So, of course, Burp Suite, one of those tools that's very useful to have around, whether you're doing web or mobile application assessments, pen testing, bug bounty hunting, or even debugging features in web app development. So, here's a guide on how to install Burp Suite on different platforms. Now, hopefully you know already, if you are using the attack box, Burp Suite is already installed, so you can go ahead and skip this step. So we'll just skip this task since we are using the attack box, right? So we'll move on to task 5. And here's where we explore how to use Burp Suite in the attack box. So, of course, you may use the pre-installed Burp Suite Community Edition in our attack box. So to launch that attack box, just click Start Attack Box. It's the button at the top of the page. Now, once you launch Burp Suite and accept the terms and conditions, you'll be prompted to select a project type. So in Burp Suite Community, the options are limited, and you can simply click Next in order to proceed. But see, the next window allows you to choose the configuration for Burp Suite. And it's generally recommended to just keep the default settings here. So just click Start Burp and open up the main Burp Suite interface. So when you open Burp Suite for the first time, you might just encounter a screen with training options. Of course, it's highly recommended to go through these training materials when you have the time, but not on our time, so take the time on your time. If you don't happen to see the training screen, or when you come back for subsequent sessions, you're actually going to be presented with that Burp dashboard. And yeah, I must agree, it might just seem a little overwhelming at first. However, you're going to be real familiar with it soon. You'll see that the Burp dashboard is divided into 4 quadrants, labeled in counterclockwise order. Starting from the top left, we got tasks. And here, the task menu allows you to define background tasks that Burp Suite will perform while you use the application. In the Burp Suite Community Edition, the default live passive crawl task, which automatically logs the pages visited, is going to be sufficient for our purposes right now in this module. But the Burp Suite Professional offers additional features like on-demand scans. Let's check out the event log, because the event log provides information about the actions performed by Burp Suite, such as starting the proxy, as well as details about connections made through Burp. And here we've got issue activity. This is the section that is specific to Burp Suite Professional. So it displays the vulnerabilities identified by the automated scanner, ranked by severity, and filterable based on the certainty of the vulnerability. Right? And here's where we get to the advisory section. And this provides more detailed information about the identified vulnerabilities, including references as well as suggested remediations. This information can be exported into a report. And in Burp Suite Community Edition, this section may not actually show any vulnerabilities, but don't let it get you down. Now, throughout the various tabs and windows of Burp Suite, you're going to notice question mark icons. Just by clicking on these icons opens up a new window with some very helpful information specific to that section. You'll notice these help icons are invaluable when you get stuck or need some assistance for something, maybe some clarification on a particular feature. So go ahead, click them, use them effectively. That's what they're there for. Now, the question is, what menu provides information about the actions performed by Burp Suite, such as starting the proxy, and provides you details about connections made through Burp? Yeah, the actions event log. Moving on to task 6. Here's where we learn about the navigation within Burp Suite. You ready? All right. So within Burp Suite, the default navigation is primarily done through the top menu bars. See, and these allow you to switch between modules and access various sub-tabs within each module. The subtabs appear in a second menu bar directly below the main menu bar. So let's walk through how the navigation actually works. Modules section, the top row of the menu bar, will display the available modules in Burp Suite. So here you can click on each module to switch between them. For example, the Burp Proxy module is selected in the image here. Subtabs. If a selected module has multiple subtabs, go crazy. They can be accessed through the second menu bar that appears directly below the main menu bar. So these subtabs often contain module-specific settings and options. For example, in the image here, you will see the Proxy Intercept subtab is selected within the Burp Proxy module. Now, if you prefer to view multiple tabs separately, you can always detach them. That'll make them into separate windows, right? So all you have to do is go to the window option in the application menu above the module selection bar. From there, choose the detach option, and the selected tab will be open in a separate window. So the detached tabs can actually be reattached using the same method. Okay, so the Burp Suite here also provides keyboard shortcuts for some quick navigation to some of your key tabs. And by default, here are the shortcuts that are available. Control Shift and D brings up the dashboard. Control Shift and P is the proxy tab. So how about some questions and answers? And yeah, the natural answer would be the proxy tab, which is where we learn about configuring Burp Suite settings. Now, before we go diving into the Burp Proxy, we need to explore the available options for configuring Burp Suite. Everybody loves options, and we want to show you that there's a couple of types of settings here. We got global settings, also known as user settings, and per project settings. So having a look at global settings first, these settings obviously affect the entire Burp Suite installation and are applied every time you start the application. So they provide a baseline configuration for your Burp Suite environment. Project settings. Yeah, so these settings are specific to the current project and apply only during the session. However, you got to note that Burp Suite Community Edition does not support saving projects, right? So any project-specific options will be lost whenever you close Burp, but that's okay. Now, in order to access the settings, just click on the Settings button at the top of the navigation bar, and this will open a separate Settings window. In the Settings window, you're going to find a menu on the left-hand side. This menu allows you to switch between different types of settings, including search. Enable searching for specific settings using keywords. Type filter filters the settings for user and project options. User settings show settings that affect the entire Burp Suite installation. Project settings display settings specific to the current project. And categories, which allow selecting settings by category. Now, of course, it's worth noting, too, that many tools within Burp Suite provide shortcuts to specific categories of settings. For example, the Proxy module includes a Proxy Settings button that opens the settings window directly to the relevant proxy section. The search feature on the settings page is also a valuable addition. And this, of course, allows you to quickly search for settings using keywords. But definitely take some time to familiarize yourself with the range of configurable options in Burp Suite. Then once you're comfortable, you can go ahead and proceed with the exercises related to configuring Burp Suite settings. But first, let's do some questions and answers. Question number 1. In which category can you find a reference to a cookie jar? Now, to find the answer to a question, probably do need to change over to the search panel. Question number 2. In which base category can you find the update subcategory, which controls the Burp Suite update behavior. And again, you can just go ahead and use the search button. And of course, the name of the subtab is Suite. Question number 3. What is the name of the subcategory which allows you to change the key bindings for shortcuts in Burp Suite? What's the answer? That's going to be hotkeys. Question number 4. If we have uploaded client-side TLS certificates, can we override these on a per-project basis? The answer is, oh yeah, we can. All right, we're going to move on to task number 8. So the Burp proxy is a fundamental and extremely significant tool within Burp Suite. It enables a capture of requests and responses between the user and the target web server. And this intercepted traffic can be manipulated, sent to other tools for further processing, or explicitly allowed to continue to its destination. There's a few key points to understand about using Burp proxy, though. So let's walk through them. Intercepting requests. All right. So when requests are made through the Burp proxy, they are intercepted and held back from reaching the target server. The requests appear in the Proxy tab, allowing for further actions such as forwarding, dropping, editing, or sending them to other Burp modules. To disable the intercept and allow requests to pass through the proxy without interruption, just click the Intercept is On button. Second, taking control. The ability to intercept requests empowers testers to gain complete control over web traffic, making it invaluable for testing web applications. 3. Capture and logging. Burp Suite captures and logs requests made through the proxy by default. So even when the interception is turned off. This logging functionality can be very helpful for later analysis and review of prior requests. 4. WebSocket support. Burp Suite also captures and logs WebSocket communication, providing additional assistance when analyzing web applications. 5. Logs and history. The captured requests can be viewed in the HTTP history and WebSockets history subtabs. And this allows for retrospective analysis and sending the requests to other Burp modules as needed. Also, proxy-specific options can be accessed just by clicking the Proxy Settings button. These options provide extensive control over the proxy's behavior and functionality. So, go ahead, familiarize yourself with these options to optimize your Burp proxy usage. So how about we walk through some notable features in the proxy settings? First up is response interception. So by default, the proxy does not intercept server responses unless explicitly requested on a per-request basis. The intercept responses based on the rules checkbox, along with the defined rules, allows for a more flexible response interception. Number 2. Match and replace. So the match and replace section in the proxy settings enables the use of regular expressions, or regex, to modify incoming and outgoing requests. And this feature allows for dynamic changes, right, such as modifying the user agent or even manipulating cookies. We'll have fun with that later. Now, you got to take the time, though, to explore and experiment with the proxy options, because, again, it's going to enhance your understanding and proficiency with the tool. Check it out. There's really no need for that question, so let's just skip it, all right? Yeah, let's move on. Here we got task number 9. Yeah, here's all about using the Burp browser. All right, so let's start up the machine just by clicking the Start Machine button at the upper right-hand corner. Now, to use the Burp Suite proxy, we will need to configure our local web browser to redirect traffic through Burp Suite. So in this task, we'll focus on configuring the proxy using the Foxy Proxy extension. Yep, in Firefox. Now, since we are using the attack box, we don't need to do these configurations, but if you do need any further information for your own OS, go ahead. You can just have a little read here to familiarize yourself, because we're going to move on to task 10, the Target tab in Burp Suite. This offers more than just control over testing scope. It actually consists of 3 subtabs. Let's have a look. The first is Sitemap. This tab allows mapping of targeted web applications in a tree structure. Every visited page while the proxy is active appears on the sitemap. Now, it automatically generates a sitemap by browsing the web application. In Burp Suite Professional, it enables automated crawling, exploring links between pages, and mapping out the site. But even in Burp Suite Community Edition, it helps accumulate data during initial enumeration, particularly for mapping out APIs. Number 2, we got issue definitions. So despite Burp Community lacking full vulnerability scanning, it does provide a list of vulnerabilities that the scanner checks for. So the issue definition section offers an extensive list of web vulnerabilities with descriptions and references. Very useful for reports or describing identified vulnerabilities during manual testing. Number 3, scope settings. This feature controls a target scope, allowing inclusion or exclusion of specific domains and IPs. But managing scope enables focusing on targeted web applications and avoiding any unnecessary traffic capture, which, believe me, you may just want to do. But overall, the Traffic tab is going to offer features beyond scoping, including mapping web applications, refining target scope, and accessing a comprehensive list of web vulnerabilities for reference. Which brings us to the challenge. So the challenge prompts exploration of a site on a given IP, visiting every linked page on the home page, and checking the sitemap. An unusual endpoint stands out in the sitemap, so by clicking on it, the response section reveals the flag. So let's go ahead and try and solve the challenge. So first, click Open Browser, input the target IP. Then, attempt to visit every accessible page on the site without navigating away from the sitemap. Then, review the Target tab under the host to identify the unusual endpoint mentioned in the challenge, and click on this endpoint to access the request and response sections, where you should be able to find the flag. All right, moving on to task 11. Now, if the previous task seemed overly complex, rest assured this topic will be a lot simpler. But it's all for good purpose, right? So, in addition to modifying our regular web browser to work with a proxy, Burp Suite also includes a built-in Chromium browser that is pre-configured to use the proxy without any of the modifications that we've just been through. That's why we saved this for the end here. Anyway, to start the Burp browser, just go ahead and click on Open Browser. It's the button in the Proxy tab. And you will soon have a Chromium window pop up. Any request made in this browser will go through the proxy. I do want you to note, though, that there are many settings related to the Burp browser in the project options and user options settings. So you got to make sure to go back and explore and customize them as you like. However, if you're actually running Burp Suite on Linux as the root user, as is the case with AttackBox, by the way, you may actually encounter an error preventing the Burp browser from starting, and that's due to the inability to create a sandbox environment. But don't worry, there's a couple of really simple solutions to this. Smart option: create a new user and run Burp Suite under a low-privileged account to allow the Burp browser to run without issues. There's an easier option: go to Settings, Tools, Burp's Browser, and check the Allow Burp's Browser to Run Without a Sandbox option. So, enabling this option will allow the browser to start without a sandbox. However, you got to be aware that this option is disabled by default, and that's for security reasons. So if you choose to enable it, exercise caution, as compromising the browser could grant an attacker access to your entire machine. Now, in the training environment of the attack box, that's unlikely to be a significant issue. But that's why I'm bringing your attention to it. You got to use it wisely and responsibly. Now we get to task 12. So here we're going to have a look at scoping in Burp Suite. All right? So we've come to, well, one of the most important aspects of using the Burp proxy, and that would be scoping. So capturing and logging all of the traffic can quickly become overwhelming and inconvenient, especially when you only want to focus on specific web applications. That's why you got to learn how to use scoping. So by setting a scope for the project, we can define what gets proxied and logged in Burp Suite. You follow? So we can actually restrict Burp Suite, and it'll target only the specific web applications that we want to test. Now, the easiest way to do this is just by switching to the Target tab, right-clicking on our target from the list on the left, and selecting Add to Scope. This way, Burp will then prompt us to choose whether we want to stop logging anything that is not in scope, and in most cases, we do want to select Yes. Now, to check our scope, we can switch to the Scope Settings sub-tab within the Target tab. All right? Now, the Scope Settings window allows us to actually control our target scope by including or excluding domains or IPs. Now, this section is very powerful, and we're spending some time getting really familiar with it. However, even if we disable logging for out-of-scope traffic, the proxy is still going to intercept everything, right? Now, to prevent that, we'll actually need to go to the Proxy Settings sub-tab, select And URL is in target scope from the Intercept Client Requests section. So enabling this option ensures that the proxy completely ignores any traffic that is not within the defined scope, resulting in a much cleaner traffic view in Burp Suite. All right, so moving on. Yeah, let's skip task 13, huh? Now, task 14. First, we'll navigate to the support section where we will input a valid email address and our message. Then after composing our message, we proceed to the per fit section and perform an enters. Then we do 10 and observe that Pepsi has intercepted our request. So we delete it and paste a joystick group here. And upon doing that, we return to our page. And there you go. You can see that our XSS tag was successful. So here we can just click on No Answer Needed and proceed to the conclusion section. So now we're in task 15. We'll conclude the Burp Basics room. And check it out. Congratulations. You've completed the Burp Basics room.